All right, welcome to Mr. Lehan Teaches You Stuff. This is Grade 9 Chemistry Lesson 5, Elements and the Structure of the Atom. So an element is a substance that contains only one type of atom. So here we have the periodic table of elements. We've got around 118 elements here. And for each one of these elements, it contains a very specific type of atom that is unique to that element. And you'll know something's an element because elements cannot be broken down through chemical means. So that means if you put it in any sort of chemical reaction, it doesn't matter what kind, that element will never turn into another element or break down into something else. It's always going to stay that element. Now an atom is the smallest bit of an element that you can have that is still that particular element. And here's what I mean by that. If we take an element, let's say gold, if we take a bar of gold and we split it in half, what we now have is two pieces of gold. They're slightly smaller. So let's keep doing that. Let's split it again and again and again and again and again until we get smaller and smaller and smaller pieces of gold. Eventually you'll have a piece of gold so small that you can see the individual atoms that make it up. That's how small it is. And we keep splitting it more and more and more, and just picking up one of the pieces, we'll eventually have a piece of gold that's only 2 atoms big. Now if we split that in half, we end up with just 1 atom of gold. Now the thing is, we can't split that 1 atom of gold and still end up with 2 pieces of gold, because this is the point at which things stop being gold. So this is an element. It's made up of protons, neutrons, electrons. If we split this in half, if it was possible to split this in half, you wouldn't end up with gold anymore. You'd end up with a big mess of subatomic particles. So it would no longer be an element, or maybe it would be 2 elements. But that's what an atom is. An atom is the smallest bit of an element that you can get. So each atom has a nucleus and electrons in orbit around it. So in my picture here, we've got the nucleus at the center, and we have these electrons orbiting around the nucleus. Now I should warn you, this picture is not to scale. If I drew an atom this big on the screen, you would not be able to see the electrons because they're so small, and you also wouldn't be able to see the nucleus because it's so small. In fact, the nucleus is extremely small compared to the rest of the atom, so it's 1/100,000th the size. That means if we had a nucleus about this big, which is around 2 centimeters across, the edge of the atom would be a kilometer away in either direction. So this atom would be a kilometer or 2 kilometers across. So it would be extremely large. Another way people like to explain this is if you had a nucleus the size of a pea, the atom would be the size of a football stadium. So an atom is mostly empty space. That's what we're trying to get at here. Mostly empty space. The very little mass that it has is concentrated mostly in the nucleus. So we should go through the subatomic particles. These are all the bits that make up the atom. There's 3 main subatomic particles, and they're protons, neutrons, and electrons. So the protons are positively charged particles, and they're in the nucleus. So those are the green guys there. The neutrons, also in the nucleus, are neutral particles. So we'll just give those an N. And then the electrons, we've already pointed those ones out. These are the negatively charged particles that orbit the nucleus. Now, a regular atom does not have a charge. So it's not going to be positively charged or negatively charged, which means that the positively charged protons are going to equal the negatively charged electrons. So in this case we have 1, 2, 3, 4, 5, 6, 7 electrons. So to balance that out, there must be 7 protons. And incidentally, there's 7 neutrons in this case too. But the 7 protons is the important part. So this atom balances out because it has 7 protons and it has 7 electrons. All right, the atomic number. This will be very important when we get to the periodic table. This periodic table pictured here just has the atomic number on it. So on the top left in the periodic table, there's usually an atomic number there. Each element has its own atomic number. And the atomic number is the number of protons an atom of that element has. It's kind of confusing. Why don't we just say atomic number equals number of protons? So for any element, the atomic number is the number of protons it has. If two atoms have the same number of protons, they are the same element. So what I'm saying here is that an atom, or an element rather, is defined by the number of protons in an atom. So if two atoms have the same number of protons, they must be the same element. If two atoms have a different number of protons, then by definition, they are different elements. Now we'll look at relative mass. Protons and neutrons are roughly the same mass, so we basically consider them to have the same mass. The electron, on the other hand, is about 1/2000th the mass of a proton or a neutron. So if we look at our scale again here and we have a proton on the left, we would need around 2,000 electrons on the other side to balance it out. So that being said, the mass of an atom can be considered to just be the mass of the protons and neutrons added together, because the electron contributes so little of the mass. You know, there's no atom that we know of that has 2,000 electrons. There's no way that would be stable. So there's no way that it can even amount to the mass of just one neutron. So we just ignore it. So if we're looking at atomic mass, protons and neutrons are given a relative mass of 1 atomic mass unit, or AMU. And we use this atomic mass unit instead of using like kilograms or grams, because then the numbers would just be silly. For example, if we wanted to measure what one neutron or one proton would weigh, it would weigh decimal 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 called the atomic mass unit, which weighs as much as a proton unit of measurement called the atomic mass unit, which weighs as much as a proton or a neutron. Because electrons are so light, they're given a mass of 0. We just consider them to have no mass. And then the periodic table shows you the atomic mass. And the atomic mass is the number of protons plus the number of neutrons. So here we have a box from the periodic table. And in this box we have the atomic mass at the bottom. And you'll know it's the atomic mass because it'll probably be the biggest number in there. Because remember, at the top left there, for oxygen here, we have an atomic number of 8. That's the number of protons. So at the bottom, we have the atomic mass, which is the protons plus the neutrons. And it's got to be bigger than just the protons. So we have 8 protons, 8 neutrons. That gives us an atomic mass of 16 for oxygen. Right, that's it for this video. So tune in for the next video, the periodic table part 1.